Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0697 indicates a malfunction in the sensor reference voltage 3 circuit of the Honda Accord models from 2017 to 2023. This circuit is crucial as it helps in providing a stable voltage reference to various sensors in the vehicle, ensuring accurate readings for efficient engine management and performance. When this code is triggered, it suggests that the transmission control module, TCM, is not receiving the expected voltage signal from the related sensor, which can affect the functionality of the engine and transmission systems. The symptoms might not always be evident initially, but can lead to significant operational issues if not addressed promptly. Understanding the implications of this error code helps in performing appropriate troubleshooting steps, leading to effective repairs and the restoration of normal vehicle operation. This presentation aims to guide through the diagnostic steps necessary for addressing the P0697 DTC efficiently. The error described by DTC P0697 pertains specifically to the sensor reference voltage 3 circuit malfunction. This circuit primarily affects the countershaft speed sensor, which plays a critical role in monitoring the speed of the transmission's countershaft. This sensor is strategically positioned within the vehicle's transmission assembly and provides essential data to the transmission control module, TCM. The TCM relies on this information to determine the appropriate shift timing and other vital operations for smooth vehicle performance. If the sensor fails to provide accurate voltage readings, it can impede the TCM's ability to control the transmission effectively, leading to poor performance or operational failures. The location of the countershaft speed sensor within the transmission necessitates careful attention during diagnosis and repair, as accessing it may require disassembling parts of the transmission. Proper understanding of the component's role and location aids in efficiently addressing the code. Multiple factors may contribute to the occurrence of DTC P0697, each requiring careful investigation. First, a faulty countershaft speed sensor is a leading cause, indicative that the sensor may be damaged or malfunctioning, thereby failing to send accurate voltage levels to the TCM. Second, a shorted wire to ground in the VCC3 line could prevent the sensor from transmitting the proper signal due to a broken or poorly connected wire, leading to ineffective operations. Third, a shorted wire to power also presents a potential issue that can disrupt the voltage levels and could allow excess voltage to reach the sensor, adversely affecting the TCM's performance. These underlying causes highlight the need for thorough troubleshooting to identify and correct the specific failure area responsible for the DTC. Only by addressing each possibility can the issue be resolved effectively, ensuring reliable vehicle functionality. The symptoms manifested from DTC P0697 often include the illumination of the check engine light on the dashboard, signaling an underlying issue that necessitates attention. Additionally, drivers may experience noticeable transmission performance issues, such as erratic shifting, delayed engagement, or even complete loss of power, further indicating that the transmission control module is not receiving accurate data. Such symptoms might compromise the overall driving experience and can lead to increased wear and tear on the transmission if left unaddressed. Moreover, it is common to see additional DTC codes related to the transmission, suggesting a cascading effect on the vehicle's systems caused by the failure in the voltage 3 circuit. Recognizing these symptoms is vital in prioritizing repairs and ensuring vehicle safety and efficiency. Addressing these issues promptly can prevent more extensive damage and costly repairs down the line. The first step in troubleshooting DTC P0697 involves verifying the problem through a series of checks. Begin by turning the vehicle to the on mode without starting the engine, which allows the systems to energize and the modules to communicate. Following this, utilize the Honda Diagnostic System, HDS, to clear the DTC, which helps reset the vehicle's computer system and can eliminate transient issues. After clearing the DTC, turn the vehicle off and then back to on mode to check for any pending or confirmed DTCs once more. If DTC P0697 reappears, it verifies that there is a persistent issue that needs to be addressed further. Conversely, if the code does not return, it could indicate an intermittent failure, and further inspections for poor connections and loose terminals at the TCM may be warranted. This preliminary step is crucial as it lays the foundation for all subsequent diagnostic efforts. In the second step of troubleshooting DTC P0697, you must focus on the countershaft speed sensor, as it's a critical component linked to this code. Begin by turning the vehicle to off mode to ensure safety while performing electrical disconnections. Once safely powered down, disconnect the 3P connector from the countershaft speed sensor. This action isolates the sensor, allowing for more accurate testing of the circuit's integrity. After disconnection, turn the vehicle back to on mode and once again use the HDS to clear the DTC. Following this, check for any pending or confirmed DTCs. If DTC P0697 reappears, it indicates that the sensor itself is likely at fault, leading the technician to proceed to the next steps for repair or replacement. If it does not appear, then the countershaft speed sensor may not be the source of the problem, and further investigation of the wiring and connections would be necessary. The third step in troubleshooting DTC P0697 involves checking for shorted wires. Begin by turning the vehicle to off mode to mitigate any electrical hazards when disconnecting components. Next, detach the TCM connector A, which is a 23P connector linked to the transmission control module. Ensuring that the vehicle remains in the off mode, check for continuity between test points using a multimeter. Test point 1 is at the number 1 female terminal of the disconnected countershaft speed sensor 3P connector, and test point 2 is to body ground. Establishing continuity in this manner indicates that there is a short to ground in the VCC3 wire between the countershaft speed sensor and the TCM. It's essential to interpret these findings correctly to ascertain where the actual faults lie, so proper diagnosis can be achieved, leading to effective repairs. If no continuity exists, this suggests the wire is not shorted to ground, and further checks are required. In the final troubleshooting step, you must assess the voltage levels present in the circuit to determine if a short to power exists. Start by turning the vehicle to the on mode without starting the engine, thus allowing the electrical systems to engage. Again, with both the countershaft speed sensor and TCM connector A disconnected, measure the voltage at the specified test points using a multimeter. Test point 1 remains at the female terminal number 1 of the countershaft speed sensor 3P, while test point 2 is to body ground. The goal is to determine if the voltage measures 7.2 volts or more. If this threshold is met, it indicates there is a short to power condition in the VCC3 wire, necessitating repair to correct the circuit. Should the voltage be lower than this, the VCC3 wire is deemed functional, and the technician should seek authorized service information related to the DTCs, or consider replacing the TCM with a known good unit. This last step confirms the functionality of the wiring and components for appropriately resolving the. After completing the repairs related to DTC P0697, it is critical to verify that the issues have been resolved effectively. Start by using the Honda Diagnostic System, HDS, to clear any existing diagnostic trouble codes. Following this, perform a test drive of the vehicle under various conditions to ensure that everything operates smoothly and that no transmission control module, TCM, issues reoccur during normal driving scenarios. It's important to closely monitor the check engine light and ensure that it does not illuminate after the drive. After the test drive, recheck with the HDS for any pending or confirmed DTCs. This verification step is essential to confirm that the repair has been successful and that the vehicle is operating as intended. If any codes return, further investigation may be required to ensure thorough resolution of the initial faults. This process helps maintain vehicle reliability and performance. Preventive maintenance for the vehicle is crucial in avoiding triggers of DTC P0697 in the future. Regular inspections of the countershaft speed sensor, along with other related sensors, help ensure that they are functioning correctly and that wiring remains intact. It's also advisable to routinely check all wiring connections associated with the sensor and the TCM. Loose or corroded connections can lead to communication errors, which may cause similar DTCs to arise. Additionally, maintaining cleanliness within the engine compartment, and especially around sensor and wiring areas, helps prevent contamination that could lead to electrical faults. Keeping a checklist or service history can be beneficial in tracking maintenance performed and scheduling future inspections proactively. By adhering to these preventive strategies, owners can mitigate the risk of electrical issues and their associated repair costs, ensuring a longer life for the vehicle's components. In conclusion, understanding the implications of DTC P0697 is fundamental for effective vehicle maintenance and repair. This code signifies a malfunction in the sensor reference voltage 3 circuit, affecting the performance of the countershaft speed sensor and thus the TCM. Following the detailed diagnostic steps outlined ensures that technicians can identify the root cause of the issue efficiently and implement appropriate repairs. Furthermore, adopting regular maintenance practices is key to preventing the occurrence of similar DTCs in the future, fortifying the vehicle against unexpected failures. Conclusively, being attentive to such diagnostic codes and adhering to a rigorous troubleshooting process allows for sustained vehicle reliability, enhanced performance, and reduced repair costs over time. Please like and subscribe to the channel. See you next time.